Hello again, welcome once more to the desk. Episode 4 of this little series. What we're going to be looking at here is pushing some buttons. As you can see from the little picture, if I zoom in on that, we'll be able to see exactly what we're doing here. I have modified the board slightly. So what we've got, I find a suitable pointy stick. We have a red LED, which is lit. We have a green LED, which isn't. We had those before. The difference is they're now... they've got their own resistors, they're talking to different pins. We can control them independently instead of it being one value and it's this value or that. There's reasons for doing that. We can play about with it. I could put them both on, I can turn them both off. We also have a yellow LED over here, which again has its own little resistor. These are connected to different pins, so again I can control that separately. It's over here because it's not part of the signal. This is just a little thing. And then down here we've got a green button, a red button, and a blue button. The code is exactly the same as we left it. The circuit diagram, if we come back to here, looks like this. So here's the red, green, yellow LEDs with their resistors and the push buttons. Push buttons just connect directly to ground. Normally, what you would do is you would have another resistor here connecting to positive. So basically this side of the switch is normally logic high through a resistor. When you press the button you connect it to ground, so this pin is either logic high through a resistor or directly to ground. Directly to ground will take priority because there's lower resistance, so you can switch it. I've not wired those in. We will have a little look at why in a sec. But this code, as we did before, I'll just bring the little board back up, works here. So red on, take green, red LED goes off. The green one doesn't come on yet because it doesn't exist. So what we need to do is make a few little changes. And I already typed a lot of this, so I can do this as a copy and paste operation, which works quite nicely. So I can do that. Now, I'm just going to put a little heading above that. Hardware definitions. This is a useful section to put in. I'll put a space underneath it. This is basically saying, put a few tabs in as well, might make it a little bit easier to read. This is saying what physical hardware we have connected to the board and where. So I've got a red LED, it is connected to pin 2. Green LED is pin 4, yellow LED is pin 5. The blue button 18, red button 19, green button 21. Okay, we also need to change this section here to start with so that it knows about the LEDs. So I'm going to do that because it's quicker than typing it. And what this is going to do, in fact, let's just neaten this up a little bit and put these on single lines. In C, the semicolon marks the end of the line. So you can do lines like this quite happily. Again, I'll put a couple of tabs in. Tabs don't matter either. You can use them to your heart's content to line things up visually. Makes it look nice. So what I'm saying here is pin mode, red LED, it's an output. And I'm going to turn the red LED on to start with. Green, it's an output, off. Yellow, output, off. Also going to define the buttons, which is potentially a useful thing to do as well. So we're going to put these here. Now these are slightly different. Pin mode, again, pin number. Instead of saying it's you've got a choice here. You can say this should be an input, which will just read it, or an input pull up. And what this does, bring this back up, is inside this box, the ESP32, there is a resistor that can pull this pin up to the supply voltage. The Arduinos have got those as well, so you can have input pull up on an Arduino. The ESP32, you can also have an input pull down. The Arduino doesn't have that, so I'm not using that. Basically everything on here would run on an Arduino as well, although you'd have to probably use different pin numbers because it doesn't have this. The pins are different on the Arduinos. So that is our hardware. I do need to change a few things down here as well. In fact, I'm actually going to do another little section here to start with. There's a few other things we need to make this next section work. So I'm going to do this. I'm going to have this here. Now, okay, so what's this? These are what's called global variables. If they're at this bit at the top, anything in the code can see them. In normal computer programming, it's not particularly good practice. When you're dealing with a microcontroller, it's fine because you have complete control over the machine. You're not bringing in, well, yeah. Sometimes you're going to bring in code libraries which step on some of these things. Yeah. But what I've got here is a bool, which is a boolean. Boolean can be true or false. That's all it is. Just true, false, can't do anything else. Changed. So if the input has changed, if we want the lights to change, that's going to be true. And I'm starting it as true because I want to set the lights on the first cycle, and that's the easiest way of doing it. Current state, red and green, is 0 and 1. You can have other things in there as well. I mean, here we could just say I'm actually just using the lowest bit, and you could have 8 signals run off that. I'm not doing that, I'm just using that. Now, what this means is we can change this code here slightly. Because at the moment, what this code is doing is saying, if I'll just grab one of these little bits first off to bring in. This code here is saying if we've sent a green, I originally turn the LED off and then send proceed. Well, I don't want to do that. What I want to do is that. So current state, I want to say set the state to 1, which is green. And down here, set the state to 0. And we always set changed is true. We have made a change to that value, so we need to tell the system we've done it. And well, why would we do this? Well, this is input logic and sort of decision making is what we've got on here. So what we're now going to do is we're going to come down to the bottom and we are going to have the output stage. And the output stage looks like that. So now we can have multiple things generating inputs, but we only have to do the output bit once. You can probably guess where this is going by the fact we put some buttons on, but that's how this works. So this is saying if we've gone into state of red, turn the red light on, turn the green light off. If we're green, turn the red light off, turn the green light on. You could play about with the order of these, and yeah, in theory, I will always turn the light that's on off before I turn the other light on. You're not going to notice. If you were doing this as safety critical programming, for God's sake, don't follow my advice, whatever you do. But there we go. And then down at the bottom, the very last line, we reset, we clear this changed flag. We have made a change, so we don't need to do it. And what this means is this bit of code here will only run once when we change something, and it won't run again until we change something else. Let's run that, see what that does. So again, to compile, and the only difference this should do is the yellow light should go off, and we should be able to turn the green and the red one on through the serial port. There we are. So we start like so. Come in here, I'm going to tell that clear, and I'm going to say, I want that signal to be green. There we are, green, and proceed. I want it to be red. Red. Okay, that bit works. What we now need to do is think about, well, okay, the serial port bit works. How are we going to make the buttons work? And more to the point, where are we going to put the code for the buttons? Now, you see, when we did this loop, we set it up so that red is dominant over green. We can set the value to be green, and then we can overwrite it to be red. So red is dominant. I'm also going to make the buttons dominant to the serial port. So you can send what you like on the serial port. If the buttons say no, you're not doing it. So how do we read the buttons? Well, we need, again, a couple more global variables. Now, if we just wanted to read the buttons, you don't need to do this. But because we want to read the buttons and remember how they're set, because we're going to do some logic with it later, we need some more variables. And I'm going to use this flags variable. In fact, I'm actually going to go in and type this one out in full as well. So what on earth are we doing here? And that code also goes there. Now, I'm going to use two variables here. You say up here we've got a flag. This flag just stores a single value. This flag can store 8 values. And I'm going to use this bit, that bit there that I've highlighted. That is bit 0, because we start at this side. That's going to say, what is the green button doing? That bit is going to say, what is the red button doing? And that bit is going to say, what is the blue button doing? And this here is, right, these are the flags. So we can set how these things work. But we can also say, if that value is 0, nothing's changed. If it's any number other than 0, so it could be a 1, it could be a 2, it could be a 4, it could be any combination of those, it could be, depending on which buttons are pressed, do something. We'll come back to whether we exactly what we're going to do with that one in a bit. And then button state is basically what is the known state of these buttons. Okay, that's fine. So again, it's going to be a 1 1 whatever. So what we need to do is have a little look at reading these buttons. I'm going to go into here, and we need another little bit of code. Just going to sit here. And this is going to say, right, the button now is button state, but it's now as opposed to what things were. And junk is just a temporary variable I'm going to do some bits into. So what we're going to do, this. So, okay, what does that say? Well, digitalRead reads the pin. It will return a 1 or a 0, basically depending on what value the pin is at. So if here, because the way this is wired, normally this is going to return a 1. If the button is pressed, it's going to return a 0. So we are then going to say, right, what value have we got here? So if this is a 1, this means the button isn't pressed. This gets slightly convoluted. So what I want to do, I'm now saying the button values in this here, I want the flags to be a 1 if the button is pressed, because that just logically makes more sense. So here the button is not pressed. So what I need to do is 0 the bit for that button. So we have a logical AND operator. So we bring this up here. So we use this the second one of this little table here. So the value I want is going to be 0, and we're going to be looking here. So the value is 1, and this flag value here. So basically, if the value is 1, and what we'll store, and this does it for each individual bit, the value we'll store is whatever is currently there. Because if I say, right, it's a 1, and my flag value is 1, we're going to store a 1. We say it's a 0 and my flag value is 1, we're going to store a 0. So we're going to store what's already there. We put in the 0, so this is here is we're going to have the 0. Well, if it's a 0, it's going to be a 0 anyway, and if it's already a 1, it's going to be a 0. So what this bit here is doing is saying, regardless of what it currently is, set that bit to be a 0. Now otherwise, if that's a 0, because the button is pressed, what we want to do is store a 1. So what we're going to do is use this OR gate function here. So again, A is what we're doing and B is what it currently is. So if it's a 0, and I've got the 0 up here, store a 0. If it's a 1, and we got a 0 there, yeah, okay, store it as a 1. So effectively, if we're not doing anything, leave it alone is those top two values. Now here we are doing something because we've got this little 1 in here. We're always going to set it to be a 1. So these little bit operators, quite useful. To show that working, before we do anything else with it, I'm now going to drop that in. I'm going to clear what's already here, and we're going to tell this to run. And what this should do is produce a value. The button code still works. Sorry, the code for red and green still works, but we're not actually going to use that this time. What I'm going to do is reset this. Let this run. There we go. It's reading 0 because we've not pressed a button. I'm going to press a button. Green button says value 1. Now that's because it's the first bit. Red button, value 2 because it's the second bit. If I press both, we get a value of 3 because 1 and 2 is 3. Press the right button, we get a value of 4. This is because this is counting in binary. So the first bit is a value of 1. The next bit is a value of 2. Then there's a value of 4. Then a value of 8. Then 16, 32, 64, and 128. So if you know the number, you can see exactly which of these bits are set. So if I press these, press them all, we get 7. It tells me all the buttons are pressed. That's quite useful. So what we're now going to do is I'm going to take that out. Now we know that bit works. What we need to say is, has the value of the buttons changed? And what we're going to do at the bottom here, so I now go if button now is not equal to, what did I call it up at the top? Button state. Now if that's true, what that means is something has changed. And the very end of this line here is going to be button state equals button now. So if they're different, we're going to do something, and then we're going to set them to be the same. And what this basically means is this code loop will only run when something has changed. So as with up here, this only runs if there's something to read. Here it only runs if there's something's changed. And what we want to do is set the code for the buttons. So we're going to look in here, and I'm going to go if button now, and this here is this operator. Sorry, is that operator? Is that operator? Yeah. Not B, and this is going to be the green button, which we set to be the first bit. So 1, 2, 3, 4, 5, 6, 7, 8. So what we're doing is we're going to compare that value and that. And that should, you combine them both. If the button is pressed, we've got a green flag there. So if that's true, we're going to do something. And then we're also going to go here, if button now and 1, 2, 3, 4, 5, 6, 7, 8, like that, is that. And make a note over here, that is green button pressed. Here, this is red button pressed. Now remember I said about things overriding, this isn't strictly speaking perfect because we actually want red up here to override red down here, but for now we'll ignore that. So what we're going to do is we're going to say up here, if the green button is pressed, which is that one, we're going to do that. And if the red button is pressed, which is that one, we're going to do that. And this should trigger correctly. We're ignoring the blue button for now. We'll come to what the blue button's for in a minute. So let's see if this works. Hopefully it will. Run. There we are. That's on. Press that one. Green button comes on. There we are. And just to prove on the line here, I can say red. Still works. Go green. If I type red and hold the green button down and send it, red comes on. The reason red's come on is because we had the green button pressed first. So, yeah. So that's that. That's not going to give the precedence sort of thing we wanted. There's some other bits and pieces we can do later if we want to put that in. But for now, what that's showing is how to read buttons in that sort of format. What we want though, I want the blue button to do something else. I want that to act as a toggle. So when I press that, it's going to change its state. Which is a bit, okay. Because in here we're looking at these here. So if the buttons have changed, what I'm going to do is say if button now and be 1, 2, 3, 4, 5, 6, 7, 8. So that is blue button pressed. You see, here we want to do something a little bit different. We know we've pressed the button. We haven't stored its state yet until we get to this line at the bottom. So what we want to do is look at the value we've currently got and toggle it. Basically, if it's a 1, I want it to be a 0. If it's a 0, I want it to be a 1. And then what we're going to look at is we're then going to light the yellow LED, and we're going to light that in here because this at the moment is the only place of putting this. We don't have a state value for this thing here, so unless I put one up here, which yeah, why not? uint d interlock equals false is that one. And then what we're going to do is we're going to come down here in this if changed bit, and I'm going to go here if interlocked. Does it interlock or interlocked? Interlock. There we are. If interlock. So if that is on, if it's not, do something else. And what we're going to do is, I'm just going to copy that line because it's easier than typing it. Go into there. Going to set that up correctly. Yellow. And we're going to make that one high. So if the interlock is on, we're going to light the yellow light. If the interlock is off, we're going to turn the yellow light off. And we're not going to do anything with it yet. All I want to do is just toggle it. So what we're going to do here is I'm now going to say, oh, that's been pressed. So interlock equals the inverse of the interlock. That the not is an invert operator, so whatever that value is, switch it the other way around. And in fact, I can make that a bool. Is probably the easiest way of doing that. So I'll do that there. Okay, let's try that. Should get the yellow LED working. If I can get, there we are. Uploading finally. Ta-da. So on here, they work. and the interlock pin is not functioning. So what I'm going to do here is go serial.println like that. So this we're now going to do something if the blue button is pressed. So this is just to make sure that this is actually working correctly, or at least make sure that it's actually picking that LED up. Like that. Here we are. There we are. So whenever I press that, we get the interlock. It comes on. So that bit there is working. So okay. I'll just do it I'll do it the other way. If interlock else. Oh, I know. I know what the problem was. Excuse me. So interlock equals interlock, and then the one thing I forgot to do was that line. Changed equals true. So that says we're going to invert the interlock and note that we've done a change, which should, down here, I'm going to put some little text down here, so we're going to have that there. Interlock on. Interlock off. Let's run that. And what I'm trying to do here, so we've got the red and the green buttons, you press them and they do something. And this is just turning the interlock off all the time. Okay. Okie dokie. If interlock is true, false, if else interlock equals true. And then go over there, do that, back there, and put the correct character in. So yeah, try that. The beauty is I know the yellow light lights, so this should. Yeah, but again, it's debugging code. Sometimes you think, well, hang on, that should work. I can't see why that doesn't work. There we are. Now, did you see that? See if it'll do it again. There. See, I pressed it, it came on briefly and it went off again. That is the switch bouncing. For now, I'm going to live with that. Yeah, I did it again, a little flicker. We're going to come to in a later video how you handle those debouncing. You can do it in hardware, you can do it in software. I prefer to do it in hardware. I know a lot of people love doing it in software. They say, oh, it's cheaper, you don't need the components. I prefer to do it in hardware because I usually don't have switches wired like this. This is directly into the controller. I tend to have the switches wired a bit differently, but that's for a later video. Okay, so let's make this interlock do something. Well, if we've got the interlock, what we're going to say is effectively this is a signal. So we can do this here quite happily. I'm going to say this is a track circuit for the track protected by that signal. So if that's on, the signal must be red and it must not change, is how we're going to work that one. So what we're going to say up here, so in the code, I'm going to try and set the signal to green. Well, if we're only going to do that if we don't have the interlock. So if we're interlocked, we cannot change to green. So that's there. So that's basically saying, oh, let's make this a little bit more explicit. Just using that. False. So the interlock has got to be false. Basically, the yellow light has got to be off. Oh, right, now we can change it. So we're going to come down here, and I'm going to do the same thing here. So now if you play around with C++ properly, you could set this up as a class property and do all sorts of weird things. So you can basically, you only have to do this code once. I'm keeping it simple here. So again, this is saying the interlock has got to be false to make it green. And then we're going to come down here and I'm going to say, if the interlock is true, current state has got to be red, whatever current state is. Current state is 0. So that will also say, if I just press the interlock button, it's going to go that way, and that's already got the change. So let's put that in. We are near the end of this episode now, by the way, just to point this one out before people lose the will to live. Assuming you didn't lose the will to live a long time ago. There we go. Right, now, if I've set this up correctly, I can make it go green by pressing the button. I can make it go green by doing that. Press the interlock. Signal goes to red straight away. Now I can press the green button. Or indeed the red button. Now the red button, interestingly, will still run. It'll quite happily accept the signal from the red button, even though the signal's there. Green button doesn't do anything. Same as if I type green in here, nothing happens. Turn that off. Again, turn that off, and we can go back to green. Now I'm not doing it here, but what you could do is put a little line in here that says, right, you've tried setting it green while we're actually no, let's do it. Else here, ln. I'm going to go ding 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 because this is important. I'm going to do that. And I'm also going to do that down here with the button. So if interlock, do that. Oh, so it's the blue button pressed. There. We put it. Try to get it in the right place. We put it there. So now, if we try and change the signal to green when we shouldn't, we're going to get a warning. It's not just not going to do it. It's going to warn us that we've tried to do it. And you could put a warning light in here and whatever you like. So, interlock. I want the signal to be green. Ugh, there's an error. Can't do that. What if I do it that way? There's an error. Can't do it. That off. Back to green. There we are. So, in this little episode, what we've looked at is how to read buttons. We've looked at how to have the button so we store the value. We've learned how to do something with that value. We've learned how to have a button that toggles a value on and off. We've added some little decision-making logic so that we use the value of the toggled button to decide what we can do with other bits. We've implemented some very crude feedback for error conditions. This is starting to become a working way of driving a two-aspect colour light signal. Yeah, and now you could have multiple interlock inputs. Any one of which could say no, so you could have a track circuit, you could have something else that's locking it. For example, you could say, the point facing, or the point lock isn't engaged, so you can't change the point. and you can't. Sorry, you can change the point. Therefore, the signal must stay at red because the point is not locked. In the next one, we're going to have a little look at, well, what if it's not? What if you don't want to control colour lights? What if you want to move a servo? How do you do that? Yeah, that'll be the next one. Until then, as usual, likes, comments, shares, subscribes, thoughts, insults, jokes, etc. all more than welcome. Until then, enjoy the rest of your day, and thank you very much, and goodbye.